today we're going to talk about compound inequalities. Now, what compound means is that there's more than one, and compound inequalities are going to do one of two things, okay? They're either going to intersect, and if they intersect, we use this symbol, which means intersect, okay? Or they are a union, and we use this word to show union. Intersect also is used with and statements. Union is used with or statements. And we'll get more into it so you understand what exactly I'm talking about. So first of all, we have this first example. It says 3 is less than x is less than 5. So let's go ahead and graph that. I have my 0, 1, 2, 3, 4, 5, 6. And so basically, when I look at this part of the statement and read it backwards, it says x is greater than 3. Okay? So there's 1, 2, 3, 4, 5, 6. So I have my open circle at 3, and I know that I'm going to be going this way because it says x is greater than 3. But it also says x is less than 5, all right? This is an and statement, all right? These are intersecting because I put my open circle at 5 as well, and all I do is I color in between these two points. All right, that's showing an intersection. All right, now we could go ahead and write set notation for this, and the set notation would be, we would set our brackets up, x such that, okay, and basically what we do is we're going to use our inequality that we have there, 3 less than x less than 5. That's our set notation. Now there's also what we call interval notation. All right. Interval notation, what we would do with that is, because these are both open circles, okay, what we want to think about is that we can use either brackets. Brackets would be used for either less than or equal to, greater than or equal to, okay? Parentheses are used for less than or greater than, all right? Since both of these are less than symbols that we have in our example, the way I'm going to notate that is by this. I would say parentheses, 3, comma, 5. This is my interval notation. Okay, this is set notation, this is interval notation. So let's go ahead and take a look at our next example. And we're going to practice this more, so if you're not sure, don't worry about it. My next example says x less than or equal to -4, or x greater than or equal to -1. Okay, so this is what we're going to do with this. I'm going to set up my number line, and I'm going to go ahead and have my 0 here. 1, 1, 2, 3, 4, 5. So -1, -3, -5. Okay. So it says greater than or equal to -1, so I color in my circle. I'm sorry, I'm reading the problem backwards. X less than or equal to -4, so I color in my circle there, and I'm going to the left. Greater than or equal to -1, I color in that circle, go to the right. All right? So if I was to write set notation for that, I would go ahead, here's my set notation. X such that x is less than or equal to 4. I'm sorry, negative 4, or x greater than or equal to 1, negative 1. Okay? Now, if I was to go ahead and write this up using my interval, okay? Now, because it can go from negative 4 all the way down, I'm going to have it set up like this. Negative infinity, comma, negative 4. There's my bracket because it says less than or equal to. In union with, because it's going to be greater than or equal to, negative 1, comma, infinity. Okay, so there's my interval notation. And we get to use the really cool interval symbol too. Okay, so basically this is saying that it can go all the way to negative infinity up to negative 4, or it can go from negative 1 all the way up to infinity. Okay, that's what my interval notation is telling me. Okay, so let's go ahead and solve a couple of problems. Now, when we see this first problem, all right, this is an AND problem. So what we're going to do is I have negative 5 less than or equal to 2x plus 3 and, okay, 2x plus 3 less than 7. If you go through and you solve all of it, you're going to end up with negative 4 less than or equal to x and x less than 2. I'm not going to take a lot of time to solve that. You most certainly can. What you need to do is go through and solve that to make sure that my math is correct. Okay, so I set up my number line. Here's my 0. And let's see. 1, 2, 3, 4. 1, 2, 3, 4, 5. All right, so it says negative 4, or x, if I read this backwards, x is greater than or equal to negative 4. So 1, 2, 3, 4. There's my colored in circle. And x is less than 2. So there's my open circle, and I color in between the two. So my set notation for this would be x such that negative 4 less than or equal to x less than 2. All right, so just let me take a step back real quick because I might have done this too quickly and you might be going, what in the world is she doing? What I did is I took that 2x plus 3, okay, and I used it here with negative 5 less than 2x plus 3 to solve for x. But that 2x plus 3 is also used with the less than 7, and I solve for x again. So that's how I get these two inequalities, by solving this, okay? So, real quickly, my interval notation, because it's less than or greater than or equal to negative 4, I have my bracket, which is negative 4, comma, and 2. So there's my parentheses. Okay, next one. So, again, I'm using that 3x minus 8 for both the 2 and I'm going to use the 3x minus 8 with the 10 as well. Okay, going through and solving that, I have 10/3 is less than x, and I have x is less than or equal to 6. So again, I'm going to go ahead and set up. Here's my 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so x is less than or equal to 6. 1, 2, 3, 4, 5, 6. All right, and x is greater than 10 thirds. 10 thirds would be 3 and a third. So 1, 2, 3 and a third is somewhere in there. I'll have my open circle, and I color in between those two lines. All right, so my set notation. All right, I have x such that, and I have 10 thirds less than x less than or equal to 6. And my set notation. For my interval, it would be 10 thirds. I started with the parentheses because I had the open circle there, comma, 6, and with my bracket. All right, so now let's go ahead and practice some OR statements. So if I go ahead and solve this, see, I don't have to rewrite it. This isn't an and. It's not all in conjunction. It's an OR statement where it's two separate statements. So if I solve 6x minus 5 greater than 7, I would end up with x greater than or equal to 7. I would end up with x greater than or equal to 2. Please do the math and double check me. And 8x plus 1 less than 2, I would end up with x less than 1/8. So let's go ahead and graph that. I have 0, 1, 2, 3. All right. So here I have greater than or equal to 2. So 1, 2, color in my circle, and I'm going to go that way. All right. Less than 1/8. So I'm going to have my open circle somewhere in there, and I'm going to go that way. Okay, so now that we have this, what I'm going to say is I'm going to say my set notation, x such that, and I'm going to start with my lower one. So x less than 1/8 or x greater than or equal to 2. All right, so the interval notation, what I would do for that is I start off with negative infinity. We get to write that really cool symbol, comma, 1/8, a soft parentheses because it's just less than, or, oh, nope, we use the union symbol. Maybe, there we go. And we would go ahead and union with a bracket, 2, comma, infinity. All right, let's move on. Okay, so we have 3 more examples. Let's go ahead and knock these out real quick. For the first one, we're going to go ahead and we're going to solve it, and we end up with x less than 1, x greater than 6. Okay, so I graph it, double check my math please. 0, 1, 2, 3, 4, 5, 6, 7. All right, less than 1, open circle, going that way. Greater than 6. 1, 2, 3, 4, 5, 6, open circle, going that way. Okay, for my set notation, x such that, x less than 1, or x greater than 6. For my interval, it would be negative infinity. That's not infinity. Negative infinity, comma 1, union with 6, comma infinity. Okay, so now we're going to go ahead and kick it up a notch. And now what we're going to be dealing with is switching the sign. dealing with that negative coefficient. All right, remember when you have a negative coefficient with x, your symbol has to switch. And that's exactly what's going to happen. So I'm going to rewrite this, and I'm going to have negative 3 less than negative 1 minus 2x, and negative 1 minus 2x less than 5. All right, so if we go through and we solve this, I end up with 1 is greater than x, and x is greater than negative 3. Again, double check my math. So if I go ahead and I write this up, I have my 0, 1, 2, 3, 1, 2, 3, 4, greater than negative third, so I'd go that way. X less than 1, so I color this in. So my set notation, x such that negative 3 less than x less than 1. All right, so x is less than 1, but it's greater than negative 3. My interval would just be negative 3, comma 1. Finally, I have negative 2 less than negative 2 minus x, and negative 2 minus x less than 1. If I solve this, I have 0 greater than x. My symbol has to switch because I still have that negative symbol in front of the x. All right. And here I have x greater than 3. So if I go ahead and I solve this, this is going to turn into an OR statement. All right, it's not going to be an AND statement. It's going to turn into an OR statement. So I have my 0, 1, 2, 3, 4. Okay, x is less than 0. Okay, or x is greater than 3. 1, 2, 3. So this is going to turn into, for set notation, x such that x less than 0 or x greater than 3. And so then we have negative infinity, comma 0, in union with 3, comma infinity. Thank you.